Sorry, you got that.
Tennessee North is all kind of.
Yeah, right? Oh, well, speaking.
Okay, I'm going to get started. Morning, everybody.
Morning.
Did you turn the lights off? Thanks. Today, first of all, I want to just say that in the schedule, it showed that today we'd be reviewing for the midterm on Wednesday.
Oh, boy.
Yeah, this Wednesday. I thought about it and I went over it and I looked at the whole schedule and I reluctantly made the decision that we're not going to have a midterm. So I'm hoping not to
Just give me a minute to get over this.
What I did instead, which may not be any better, is that I required you for next progress report next Monday, a week from today, to submit a formal progress report from your group. And submit it as though it's an assignment, just like the other. Oh, that's cute.
What'd you do?
I don't know, I didn't do anything. Anyway, you can check under assignments for what I'm expecting you to do for that. The most important thing for me is that you show how you're doing in executing your work plan. Now, you can do that in various ways. You can list the things that you were supposed to have accomplished by now, according to your original plan, and then show me examples of things. And I don't expect things to be 100% when you show them to me. They could be something that's 20% complete, 50% complete. So I do want you to indicate what you estimate to be the percentage completion of whatever the deliverable is. And if you show me all that stuff, then that gives me the ability to really get a sense of where every team is with their work, and for me to be able to give you some direct feedback. I'll make an effort to type up notes, give you notes on how you're doing, whether there's some things that you should be doing or things that you're doing really well that I want to point out and give you a pat on the back. And I'll give it a grade. So instead of my original plan, which was to give you a series of assignments, my idea now is that your assignments will consist of work that you're doing on your semester-long project being submitted at different points in the semester. And in the end, of course, the whole grade will be a holistic decision on my part. Since all of you are taking this as a graduate level course, you're all very painfully aware that you have to get either an A or a B to pass the course. So I'm also keeping that in mind. Not to say that anyone's going to get a grade they don't deserve, though. Everybody's going to have to deserve the grade they get. The other thing you could do in that submittal next week is to ask me for a particular direction, or give me an indication of what kinds of challenges you're up against. So maybe we can if there's some issues you want me to help you problem solve that have to do with your progress and how things are going with your team. And everybody on the team will get the same grade. So I know that's not always fair, where one person is sort of doing 80% of the work and someone else is kind of slacking off. But that's the nature of teams, and that's the nature of what you'll find when you're out in the real world, so-called, working on projects. So anyway, if there is a serious problem with that, then someone could approach me on the sly and say, hey, wait a minute, this guy is really goofing off. What are we going to do? We don't have to make it terribly public. Are there any questions about that? So target next week, this time, get it in before class, so I have a chance to quickly look at it before class. Even better if you get it in the night before. I know some of you are submitting these things at 3 o'clock, 4 o'clock in the morning, and so on. And I have had a chance to look at some of those at 3 o'clock and 4 o'clock in the morning. The other thing I want to point out, which I'm sure you're all aware of, is in the documents, course documents section, Jerome has posted all the lectures so far, or at least once he started, which wasn't right at the beginning, but close to the beginning. And anyone can go and look at those. If you happen, for whatever reason, to have missed a class, or if you fell asleep during class and you wanted to know what it is that it was all about, you can go back and review these. So I know that there's some technical difficulties with them. It's hard to hear, and I'm going to try and speak up more. And unfortunately, the microphone on that camera is not a very good one. So today, I'm going to go down to talk about the topic of research. And you know, what you're doing is really research. Okay. I've used this book, which you may be familiar with, Rote and Wang, Architectural Research Methods, as sort of a general guide for putting this presentation together. But I have kind of a preamble. This whole notion of research in architecture was very popular in the 1960s and 70s, particularly late 60s, early 70s. It happened to coincide when I was in college in the 60s. And so the program I went through was called Environmental Design. And the whole notion was that architects were going to become quasi-social scientists, and that we were going to learn all kinds of methodologies that were being used by sociologists, psychologists, and so on. Big emphasis on interdisciplinary research to inform architectural decisions. That was the goal, that was the dream. It came out of a number of things. It came out of the space program, it came out of systems approach to things. And there was a tremendous amount of hope certainly in the academic community relating to architecture, that basically the profession was ignoring. But within universities, there was a great deal of hope that architecture would somehow become a much more legitimate discipline, more scientific, more able to justify decisions with hard, factual results from scientific research. Well, partly because there were these heightened expectations, the whole thing fell apart in the mid-70s. There was still a group out there in the wilderness that never quit, but most of the so-called architectural scientists gave up because it turned out to be kind of a false, it didn't turn out to be feasible. It didn't turn out to be feasible to reduce architecture into a science because there were too many variables that couldn't be controlled when you're dealing with large groups and group behavior within environments. They had all kinds of fancy titles like man-environment relations and so on. I was swept up in that. In fact, I was involved with those groups in the late 60s and early 70s. There was an organization that formed called Man-Environment Relations, and this is their first, the publication of their first national conference. The whole objective here was to bring the different sciences together with designers and ask the scientists to give us tools that allowed us to make decisions that could be substantiated with research findings. And there was a lot of effort put into this. I, in fact, made a presentation at the EDRA 5 National Conference. I was one of the people who delivered a paper there on programming and research. That was my topic back in 1974 when I made that presentation at the National Conference. So here I am today, 2 years later, full circle, and once again, there's an interest in these kinds of things. We went through this, what some people think of the dark ages in architecture, where we were all caught up in very theoretical musings about semiology and Heidegger and all of that stuff, which I was also caught up in, but now I know better. Now it's gone from theory in architecture for theory's sake, which is what it was in most of the 1980s and part of the 90s, to theory for practice sake, for the sake of practice. And there are lots of people who are being forced into, once again, trying to figure out, is there some way that architects can really, truly justify the decisions they're making based upon evidence, based upon findings, based upon some methodology that holds up, and it isn't just all intuition and gut feel, and sort of top of your head decision making, where you, as a designer, you feel you have carte blanche. You can make decisions without having to really be able to explain the basis for those decisions. So what publications like Grote & Wang that I'm using here, and others that have come out recently, this one, Inquiry in Design by John Zeisel, he was one of these early guys. In fact, he helped start the Environmental Design Research Association back in 1968. And this publication, which came out in 1969, contained papers by all of the guys that were, and gals that were doing this stuff at the time. So they're still around. They're getting older. In fact, Henry Sanoff, who was one of the founders of the Environmental Design Research Association, is kind of a friend of mine, and I collaborated with him on some stuff, and he was hired to do a post-occupancy evaluation of this building here at the School of Architecture. He retired a couple of years ago, but he was a professor at the University of North Carolina for many, many years in this area doing this kind of work. So there's this new climate in architecture that is kind of being forced on architects because of team design, because of computer models, because of all of the other participants in the team think differently than we do. They are more rational, they're more objective, they're more engineering oriented, they're more performance oriented. So our touchy-feely approach doesn't always hold up when you're in that group environment. So what tools can we bring to the table that basically kind of prove that the decisions we're making are good decisions based on some sort of evidence or some sort of research, whatever that research is like. So programming is perhaps the most important type of architectural research that we have. And it is, in fact, research. Now, a social scientist will agree with you, but a hard scientist, someone who's a physicist or a physicist or something, they'll say that's not really science, that's kind of quasi-science, where it's not precise science, imprecise science, which is kind of an oxymoron. So anyway, this is going to be relying on this text, Architectural Research Methods by Grote and Wang, to kind of structure this. So these are the 7 methods for doing architectural research, all of which are involved in architectural programming to various extent. The first one, interpretive historical, is the one that we often think of when we do precedent studies, or we look into the building typology. We say, okay, what has this building, what have other people done with a building like this in history? How has it evolved over time? Qualitative research has to do with what's the quality of the place, and it's a much more comfortable type of research for an architect, because it doesn't really rely on hard data, it relies more on sort of more subjective things. Correlational, you compare what you're trying to study with something else that's a known thing. So you can say, what can we learn from this known one to apply over to the one we're looking at? So in the School of Architecture example, you would look at another school of architecture that you feel is somewhat similar, and you would look at the relationships between what it's doing and what you should be doing. And so it's that kind of a research. Experimental research you're all familiar with, and it's what's normally thought of as scientific research, where you set up an experiment with a control group and an experimental group, and you run it through a number of experiments, and you look at the results, you analyze the results, and then if it's a good experiment, someone else does the same experiment and tries to get the same results, and the whole object is to disprove your experiment. So everybody else is repeating the experiment, and it's not that it's been proven to be true, it just hasn't been proven to be false yet, which is sort of the whole nature of the scientific method. There's simulation research. Now, simulation research is really coming to the forefront, because computer simulation can be so complex and complete these days that more and more computer simulation is occurring. And in computer simulation can be modeling something and then modeling it in a dynamic, comprehensive kind of manner. So that's a type of research as well. Logical argumentation is a research that has more to do with philosophy and logic and constructing an argument that cannot be disproven because of the soundness of the argument, and based on that sound argument, the result you're getting is one that you can say is based upon that it's true because of the argument. And that's one that isn't used very much in architecture and probably difficult to use. Case studies are a bit like the correlational studies. You're all familiar with case studies. Again, that's looking at an example in great depth for lessons that you can learn from that example that could be applied to your particular case. And then combining strategies is also probably the more typical thing that happens. Now, there's a number of layers here. And sort of the largest, the most umbrella idea is the idea of philosophy. Philosophy is sort of the whole conceptual framework within which all of these other things occur. So you have to be aware of what your philosophy is. And there's a number of different philosophies that are still current today. But this is not a class in philosophy, and I'm not going to get into it, but we have to assume that the philosophy that applies here has to do with the philosophy that supports science and supports the idea that we are rational beings and we can uncover truth through some sort of method. Then within that are theories that operationalize that philosophy. And theories then break down into strategies and tactics, which are the ways that you execute the theory. Now, research, it involves the strategies and the tactics. And a little bit of the theory. Of course, you have to, be conscious of your theory, and then build on that to go through your strategies and tactics. And that's just sort of paints a bigger picture. So as I already mentioned, the interpretive historical research approach makes certain assumptions. It's based upon looking at the past. You look at the past to try to understand the future, which is really kind of fraught with philosophical problems. There's nothing that says that the future is going to be a continuation of the past. We used to believe that. There was this thing called Eddington's arrow of time, which was the whole basis for this type of research, where you just make an assumption, yes, these things will continue. But all it takes is one catastrophic thing for the whole future to be thrown off course and to veer away. So this is not necessarily a very trustworthy approach, yet it's one that we use all the time, particularly in architecture. And you go, and there's lots of information available for this, archives, the internet, and so on. And so here are all the ways that you can put together an interpretive research program. These are all of the first column. First column are all of the sources for information. There's diaries, manuscripts, newspapers, all these kinds of things. Now, it doesn't really talk about the internet much, but that's what you're going to use more than anything. And then here's what you do and this gets back to the critical thinking stuff I was talking about. What do you do with this material? And then you have to identify and organize it. What is it? What's its value? And then once you have it organized and categorized, you begin to evaluate it. Is it a descriptive evaluation? Is it analytical? And so on. And then you create a narration about it. You tell the story that you have covered. And you tell it in a way that begins with the sources, the background, and so on, and goes all the way through to explaining it. Now, a lot of you are getting into the point where you're really getting into your thesis. And really, most of what I'm talking about today applies in that exercise as well. So, actually, let me ask you, were you required to get this book for your thesis class? No? I used to teach that class. I made this a required text. So here's an illustration. This is obviously a building that has been added to and changed over time. And so someone has documented all the changes that have occurred, and that's their little research project to understand the evolution of this building. And there's different strengths and weaknesses. I'm not going to go over these in great detail because it's too detailed. You can go back and look at it yourself and so on. But I think for me, the biggest weakness of this approach is that tacit assumption that the past will continue in a straight line through the future. I mean, there's some real strengths because there's usually a lot of information available for you to mine. Qualitative research is an interesting one, and it's one that most programming consists of. In qualitative research, you get involved. You're there. You're in the picture. You're not looking through a one-way mirror, but you're sitting in the room. You normally use this when it's extremely complex and you can't isolate variables. You can't isolate, so you have to go in and work at kind of almost a phenomenological level where you're using all of your perceptual apparatus to begin to understand something, which might be a range from feelings to things that you hear, to things that you see, and so on. These are all the different ways that you can be involved in a qualitative research project. You can be there and live with the group. This is the anthropologist problem. Anthropologists for years thought they were studying cultures, but they were actually studying cultures with an anthropologist in it. Which is part of Heisenberg's principle of uncertainty. So there's a holistic approach where you just kind of throw yourself in and all-encompassing, completely sort of engaged and completely committed. You can also do qualitative research over a long period of time in bits and pieces, fragmentary. You can go in and out of the situation and observe it and try to understand it. It says here that qualitative research is open-ended. That's one of the problems. There are no defined boundaries to it, usually. You just have to, eventually you run out of time, or you run out of budget, or you run out of something, and you just kind of stop it and do work with what you've got at that point. And, because you as the researcher are there, you're influencing the results you're getting from the research. And you're also you're the measuring device, and you're also bringing to it your biases and prejudices and your preconceived ideas. So whether or not the result is reliable depends a lot on your objectivity and your ability to kind of extricate yourself from the subject group. And so one of the things that is encouraged in this is that it becomes kind of an informal journal kind of approach, where you keep a journal and you keep track of everything that goes on, and you don't really know at the time what's going to be useful later on, but you just try to document everything. So qualitative research, which I'm going to focus on a little bit more because this is what you're doing. You're doing qualitative research. It consists of interviewing. Some of you have done that. It could be focus groups where you pull a group together and you create a discussion group. It could be a survey where you send out a number of questionnaires, or you conduct a survey. It could be a number of ways to conduct surveys, or it could be observation. You could place yourself at a vantage point and observe what's going on. If you, for example, wanted to understand how this south atrium works, you might have a chair up on the balcony and just, with no one knowing you're there, kind of just watch everything that goes on over a period of several days, and take notes in your journal and so on. And based on that, you can step back and say, well, I noticed this, this, and this. So in terms of programming, this should really work better. This works great. This is something we should build on, and so on. So when you're doing qualitative research, most of it is descriptive. Again, going back to the critical thinking thing that I was talking about the other day. So what you're doing is you're looking for, in the descriptive matter, you're looking for patterns. You're looking for what's working, what isn't working. You're looking at clusters of things, so you begin to organize in order to describe. And you might even be counting. You might even be counting how many people are doing certain activities. then once you, and the other level you can be approaching programming from is an analytical approach, where you're collecting the information, but then you're analyzing it. And in the analysis, you may be trying to contrast things, compare things. You may be looking at how you partition the information into clusters or groups of information. Yeah.
How do you get rid of your own bias when you're doing all this?
Yeah. You can't, really. You just have to be aware of it and look for where it's popping up and say, okay, I really feel strongly about this, but is this healthy for this program for me to slant it so much in that direction? Or, you know, you can't be somebody else. You're going to be you. Now, one thing you can do is you can have someone else read it and ask them, do you see a bias in here, or do you see that it's slanted too much in one direction or the other? But partly, you can't provide a completely neutral position as a programmer, because you're bringing to it a lot more. Hopefully you're bringing to it your experience and knowledge of the building type or the subject group. And sometimes not all of that can be described in words or can be written down. Sometimes it has to do with kind of a sense that you have about it. And if you deny all of that, then you're not really bringing your expertise to the table. You're just being kind of a recorder. And you do need to influence the thing, but hopefully you're influencing it in the appropriate way and not in some sort of weird philosophical way that you may be the only one in the room that feels that way, and you're proposing a building program for a building that's not yours, but it's for this group. So you need to really be sensitive to what the group's biases are and try to reflect that rather than your own personal bias. It's a tough problem because, you know, there are people who really believe very strongly that the number one issue is sustainability and energy use and so on and so forth. So that becomes kind of a self-fulfilling prophecy in the programming, that every time they see an opportunity to interject something into the program that results in energy savings, the tendency would be to immediately grab onto that and put that in there, even though it may or may not be justified. There may be some other issue that outweighs that. But because of your personal beliefs, it takes front and center. So it's a tough problem. So what you're doing is you're trying to explain for the designer what this circumstance is that they have to respond to when they're designing a building. And that comes through that qualitative, descriptive, analytical document. So once you have your findings, you have your descriptions and so on, there are different things that you have to test or you have to look for to make sure that you're not off track, to make sure you're not being unrealistic or that you're not overstating something and so on. So you look at the quality of the data that you started with. Was it reliable, or was it just something that just happened to come along? You also look for things that don't fit the pattern, that you want to make sure you didn't exclude. This is sort of the fundamental basis for chaos theory. Before chaos theory, when scientists were studying some phenomena, and they had some really strange results that was way out of the area of expected results, it would be ignored. And they would only concentrate on the results that fell within certain parameters. Then one day someone woke up and said, well, maybe we should pay attention to all these odd results we're getting. And once they started focus on those, they began to realize that there's this thing called chaos, organized chaos, and it revolutionized many sciences. And the same thing happens here. There's sort of a chaos theory of architectural program, where because you're trying to package things in unique packages, that can be, you tend to kind of, without meaning to, exclude important things that don't fit into your categories, that don't fit into your patterns. And so one of the things you have to do when you're evaluating your result is to look for those things and say, wait, I threw that out, but it's really important. It doesn't fit anywhere, but I've got to put it back. So you have to look for all kinds of things. It's always good to look for the rival explanation. You may have an explanation for something you encounter that sounds very plausible and you believe it, but then ask yourself, well, what's the other opposite of explanation for this? And you may find when you ask yourself that and you look for that other explanation, it may give you a result that you never expected that is equally valid, or may influence your original feelings about it. So there are strengths and weaknesses with this qualitative research approach. You can take in rich, holistic qualities in real life circumstances. That's what we have here. A messy situation. We have school, we have architectural education, we have students, we have faculty, we have administrators, we have technology. There's a lot of mess here. There's flexibility in design procedures allowing an adjustment of the process. So while you're going along, as you're learning about it, it's a holistic process in that, heuristic process in that, as you discover things, you can make adjustments to your process. And you're learning as you're going. It's not all predetermined. And it could be sensitive to meanings and artifacts, people's activities, and their culture. The culture of a school of architecture can only be embraced through a qualitative. You can't measure it necessarily. You can talk about how many hours people spend in the studio, the fact that some people stay up all night, and so on, so forth. But there's a qualitative aspect to that that needs to be captured. But there are difficulties. You've got a vast amount of data, and you start making selections. You start picking certain data to include, certain things to exclude, and that's an important choice you're making, and it's a reflection of your bias. It's a reflection of what you imagine the outcome to be before you start to collect your information. So you already have kind of an agenda, and it's inescapable. You're going to have an agenda. There are very few guidelines or step-by-step procedures. So you're kind of marching through the wilderness, discovering things as you're going along, because you don't have a roadmap. You're not given a map at the beginning. And the credibility of qualitative data is suspect. If you believe in this positive paradigm, this paradigm of hard science, provable, things have to be proven with measurement and results. So qualitative research is difficult, and it's not accepted in many places as research. It's kind of seen as journalism, or as novels, as fiction, or something else. But in a funny kind of way, what you're doing is a lot more like journalism, investigative journalism, than it is hard science. So very quickly, I'm going to just skim through these others, because they're not as relevant, but in some ways some of them are. This is looking at relationships between things. And here's some illustrations. And these are from EDRA, the Environmental Design Research Association, looking at the different behaviors that occur in this plaza. So based upon different things, like the amount of space, the average number of people sitting at lunchtime in these different plazas. These are different plazas in New York. So they went to these different plazas and measured how many people were using the plaza at different times, and then looked at what's provided in the plaza. Is there seating? Is there a fountain? And so on, to begin to try to understand what is the cause of certain plazas to be popular at certain times. What are the features that are built into it? So that's the relationship between the features in the plaza and the use, the frequency of the use. And here's the similar kind of thing. Now this is used a lot in urban design research and planning research. And these kinds of surveys are very often part of this kind of research, where you hand out surveys and people give you their feedback about what features cause them to behave in certain ways. So it's looking at existing patterns and trying to extrapolate from those existing patterns that you might want to replicate in your facility. And here's an interesting one that you'll be very interested in. This was a study that was done to look at juries in schools of architecture, and they found that, by and large, female students were at a disadvantage. They received less time during a jury, they were treated with less respect, and this was found through a scientific study of measuring things like the duration of the jury, how many times a student is interrupted by the teachers and jurors. Women tended to be interrupted a lot more than men. So this kind of research can be very telling and very interesting. This is a research study that I participated back in the 70s. This had to do with the idea of imageability in Kevin Lynch. Kevin Lynch, if you probably know, has written several important books that have to do with design thinking and design at an urban scale. And the idea here was that we walked into a room and we were given a piece of paper and a pencil and said, draw a map of, in my case it was Toronto. Draw a map of Toronto. And so what they did was, this is a map that somebody drew of Boston. And what they do when they study this is to see what people begin to remember as landmarks, patterns, and whatever you can remember, you draw on the map. And they did this over and over again with many, many different people. And so they began to figure out things like imageability in cities. Do people remember certain landmarks? And why do they remember those landmarks and not other things? And so that went into sort of understanding city planning and urban design and so on. I'm not going to get into this. This has something to do with statistics. I have a whole other lecture on statistics, which I thought I would give today if I got through this really fast. But obviously that's not going to happen. So, correlational research is basically more or less a statistical research, looking at things that you can measure, things that you can then, the relationship is an if-then relationship. If this occurs, then this, we know this is going to occur. Experimental research is really, really tough to do because, unlike most experimental research in our scientists, we're not able to control all the variables unless we do a very artificial, very limited, very small scale experiment. So these are some of the studies, how galleries are used, things like that. Now, the importance of all this is not so much that you would do this research, but you might look it up. you might use its results in your program. You might go to one of these studies and say, well, based on this study that was done by this group, they found that such and such, and therefore I recommend this for the program in the new School of Architecture building that you're doing. So experimental research, difficult. Simulation, easier. In simulation research, you can use digital simulations, you can use prototyping, all kinds of things. Models are simulations, physical models, digital models. It's always just a small slice of the real world, and it's fairly focused, and what you have to do is realize the impacts of the context. Logical argumentation, not going to deal with that. Case studies, you know a lot about that. It's there are different kinds of case studies. There's explanatory case studies where you are just describing and explaining. You're explaining why things are based upon what you found, and then there's purely descriptive, and then there's exploratory. So I was asked to participate in the AIA's National Case Study Project as a reviewer, and I went to a workshop, national workshop, and they sent me case studies that were being done by the American Institute of Architects, national AIA, and it was my job to review them and critique them and send back my review. I did that for a little while. So when you're combining these methods, you can pick and choose what seems to be needed for the occasion, for the particular situation you're coming up with while you're doing your programming. You might need to do a little bit of one type, and then maybe mostly qualitative research, and then maybe a little bit of simulation. Maybe you model something. So you can see that programming can be much more involved than just figuring out how many rooms and how big the room should be. It also starts to engage the behavior that might occur in those spaces and how you begin to set up a situation so that the designer understands that and designs it in such a way that those behaviors that are positive and encouraged can occur the way they should occur, and that you're not building in impediments without realizing it. You're not creating situations that make it difficult for those behaviors and activities and situations that should be occurring to occur because you anticipated them through your research. So it's a lot of stuff, and I highly encourage people to go to the library and take a quick look at this book, particularly if it can help you in your thesis. Is anybody here doing a thesis that involves what they would consider to be any of the research types here? Anybody? Yeah, a couple of you? Yeah, so you really need to be careful when you're doing that, because I've seen over and over again, and I've advised many thesis projects that involve research, that you can easily get way over your head, and it can end up being this huge thing that you took on that you didn't realize at the beginning you were taking on. The other book that I brought is much more related to, I think, to architecture, and it's in fact a newer book called Inquiry in Design. And its bias is towards how environment, behavior, and those different social sciences that were of great interest in the 60s and 70s, how they are once again able to be relevant to architects. There's a real movement in some building types, like health facilities, towards performance-based design. In fact, there's a whole national organization that is predicated on research in the health field, research into facilities, programming health facilities, where the objective is to have research-based findings for every decision that's made in healthcare. So the color of the room, the size of the patient room, the relationship between the nurse station and the patient rooms, all of that is studied, and results are then documented and shared by this national organization of healthcare designers, of healthcare architects. And that's a spreading kind of thing because, as I said at the beginning, you're going to be sitting around the table with engineers and other people who come from a much more sort of rational, prove-it kind of mentality. And you're going to be there saying, oh, I think we should do this because I think it just feels good. Or I have a gut reaction that this will be the right way to go. They're not going to give that as much weight. It's just their nature, who those folks are. So if you can come to the table and say, well, yeah, I've got some data, some findings that came out of some research that was done at such and such university that concluded that this is the right way to go, that's going to be given a lot more respect. So are there any questions, any comments? You know, I think the architectural education of the near future is going to embrace more and more sort of this kind of stuff, and less of what we have been teaching for several years now. We used to have a class called Research Methods that I taught for a while, and we had some other faculty teaching. And that was dropped because all the Ivy League schools were teaching theory and not methods. And now there's more and more schools are picking up the ball again and going back to teaching methods of theory. And I was on board. I liked the theory part. In fact, as you know, I wrote a book on it. So. Okay. That's it? Anything else? Take a look at the assignment for next week, next Monday.